Let's look at the graphs of the secant and the cosecant. These will be the easiest. We've looked at sine, cosine, tangent, cotangent so far. These will be the easiest because they're going to rely on the sine and cosine. So I'm actually going to start by refreshing our memory on what sine looks like. Sine, remember, has a 0 at 0, 0. It has its end of its wave at 2 pi. A full period is 2 pi. Halfway in the middle at pi is its other 0. At pi over 2, 3 pi over 2, it reaches its max and min, respectively, of 1 and -1. And connecting my dots, that was our sine graph. The reason I'm starting with that is because I know that cosecant is the reciprocal for sine. So similar to how I graphed the cotangent from the tangent the first time, that's how I'm going to graph the cosecant. I know that anytime I have zeros, these are going to turn into asymptotes because if I take the reciprocal of 0, I get an undefined value. We can see that around it we're going to be shooting off to infinity or negative infinity. So I have 3 asymptotes now. I know that the 1 is not going to change and the negative 1 is not going to change because those are, the reciprocal of 1 is 1, the reciprocal of negative 1 is -1. And then if I look at what happens in between, as these values get really, really close to 0, meaning we have fractions like 1/10, 1/100th, 1/1,000th, if I take those reciprocals, we have reciprocals of 10, 100, a million. So those are shooting off to infinity, approaching that asymptote on both sides. Down here in negative land, same exact story, but we're going to negative infinity. And so we have our graph of our cosecant. If I look at sine, I've looked at sine, let's look at cosine. Cosine, we start at 1. 2 pi later, it will reach its end of wave, which will be back at 1. Halfway in the middle at pi, we have our minimum of -1. At the pi over 2, 3 pi over 2, we reach 0. And connecting our dots, remember I like to do the curve at the top just because it reminds me to curve or helps me on that curve. That would be our cosine. Let's draw the secant. Same as sine, I'm going to draw asymptotes through my zeros. I'll match up my vertices, and I'm going to point them outwards. Here, if I draw one full wave, I'm going to stop it at that 0 there. I'm going to stop that one at that 0. If I want to go to the next asymptote, I just need to figure out what that was. So it'd be on the left-hand side, the negative pi over 2, and then that would tell me to curve up at negative pi over 2. On this side, it'd be 5 pi over 2. But this is a full wave. But the blues are my graphs, my cosecant and secant. So anytime I want to do the graph of secant or cosecant, I'm going to use the sine or cosine to help me with those. So let's find the graph of y equals 3 cosecant 2x minus pi over 3. The very first thing I'm going to do, and let me switch colors entirely so don't confuse you. The very first thing I'm going to do is I'm going to rewrite it using the reciprocal function, so sine in this case. And I'm going to graph this green graph first. I'm going to use this to help me graph the cosecant. So ignoring the initial problem, let me just define everything I know about the green. There is an amplitude for sine. There is not for cosecant. Cosecant goes off to infinity, goes off to negative infinity. We have all this empty space in between. There's no amplitude. So I can only talk about amplitude when I'm talking about the sine or cosine, not with any of the other 4 trig functions. I do have a period that is consistent for both the sine and the cosecant. That would be 2 pi over 2, which is just pi. And then my phase shift, I would have the negative pi over 3 turns into a positive, and I divide by 2, and I get pi over 6. So I'm actually going to graph this sine first. I'm going to go to the right by pi over 6. That's going to be the start of my wave. I know that the wave is going to end a full pi later, so pi over 6 plus pi is 7 pi over 6. That will be the end of my wave. Halfway in the middle will be my other 0, and that should be pi plus 7 pi is 8 pi over 6, cut in half is 4 pi over 6, simplify 2 pi over 3. Those will be my zeros. I also need to figure out my max and my min. Well, those are going to be 3 and -3, and remember we do have a max and min with the sine. Those are going to be at the other halfway point, so I need to figure out what those are. Pi over 6 plus 4 pi over 6 is 5 pi over 6, cutting in half is 5 pi over 12. Squeeze that in there. And then the other one, 4 pi plus 7 pi is 11 pi over 6. Cutting that in half is 11 pi over 12. And sine goes up before it goes back down. So I'd have the 3 and the negative 3. Connecting my dots, we get that graph right there. That, of course, was not what I want to graph. I wanted to graph the cosecant, but as we just did in the earlier graphs when I did the blue and black graphs, everywhere I see a 0, I'm going to put an asymptote through it. I'm going to match up my vertices, draw my curves facing outwards. And so in black, I have my y equals equation. So in some way, I want to indicate that that is my cosecant. I've labeled it with y. I've used 2 different colors. If you wanted to go back and erase or make this other one dotted, that is also fine. So if we make this a dotted line, I need to be able to tell what your final graph is. I do not mind. In fact, every single time I see a secant or a cosecant, I always draw the graph of the sine or cosine first. I talk about sine and cosine's elements. Notice I never said that this was true for the cosecant. The only element that is true for the cosecant are the 2 elements. These 2 right here, the period is the same, the phase shift is the same. Just like with sine and cosine, these are infinite. So this is just one wave. There would be another wave that matches over here and continues to the right. But it is easiest to start by graphing the sine and cosine for the secant and cosecant. So if you know how to do those graphs, you are set already.